let's convert decimal numbers to hexadecimal numbers. Let's start with a simple example, 42 to the base 10. What you have to do is you have to divide by 16. Okay, for binary you divided by 2, and octal you divided by 8, and hexadecimal you have to divide it by 16 because the hexadecimal number system uses 0 to f. Yeah, 0 to f. Well, we have 0 to 9, and instead of 10 we have a, and 11 we have b, and 12 c, and then 13 d, 14 we have e, and finally to mention 15 we have f. Okay, so 42 we have to convert to hexadecimal. So we will divide it step by step. So if you divide it by 16, you will get 2, and the remainder will be 10. Well, we can't write down 10. We have to say a. Okay, so we have to say a. So it will be 2a to the base 16. Okay, so it will be 2a to the base 16. Okay, now let's try a bigger number like 300. Yeah, let's try 300 to the base 10. So 300 to the base 10, what we have to do is, first of all, let's divide it by 16. Okay, if we divide it by 16, what will we get? Well, we have 1, okay, 1, and 140 divided by 16 will give us nearly 7, maybe 8. Yeah, 8 words, 140. So 8 times 16 is equal to 128, 140 minus 128 is equal to 12. So the remainder will be 12. Okay, so we can't write down 12. Instead of 12, we have to write down, correct, we have to write down C. Okay, and then if we divide it again by 16, okay, you'll get 1, and the remainder will be 2. So 300 to the base 10 can be written down as 1 to C, okay, 1 to C to the base 16. Okay, and now let's try a bigger number, 1235. What about that? Okay, so I'll divide it by 16 first. Okay, I will divide it by 16 first. If I divide it by 16, I will get 7. Yeah, 7 means 112. So if I divide it by 7, I will get 112. So it will be 1 and 1, 115. 115 also we can get 7. So 115 minus 112, it will be 3. Now we can divide it again by 16, and that will be 4 is the option. So 4 times 16 is equal to 64. 77 minus 64 is equal to 13. So we can't write down 13. Instead of 13, we have to write down D. So the final answer will be 4D3 to the base 16. 4D3 to the base 16. What about something like, I don't know, like 8,345 to the base 10? How can we find that? Well, we have to divide it by 16 first. Okay, we'll divide it by 16 first. If you divide it by 16, you'll get 5. And in 34, we have 2, and 25, we have 1. So the remainder will be 9. And then we can divide it again, and that will give us 3. So 48, 41 will have 2. So the remainder will be 9 again. And here we can divide it by 16. That will be 2, and the remainder is 0. So 8,345 can be written down as 2099 to the base 16. Okay, so this is how you are normally going to convert decimal numbers to hexadecimal numbers. Pretty straightforward. Now let's convert the hexadecimal numbers to decimal numbers. Okay, as we normally do, we'll start with the abacus. Okay, let's say we have 2c to the base 16. Okay, so this is what we have to convert. So let's draw the abacus first. So we have the abacus with us now. So since it is 2c, we can draw the beads without any issue. So here we have 2, and for c, you have to draw how many beads? Well, a is 10, so c will be 12. So we have to draw 12 beads. This is what we have to see. Okay, so here this one has the place value of 16 to the power 0, and the next one has the value of 16 to the power 1, which is equals to 1 and 16 respectively. Okay, so here what we have to do is we have to multiply 1 by 12 and 16 by 2. So 1 times 16 to the power, well, not 1 times 16 to the power 12, 12 times 16 to the power 0 is equal to 12 into 1, which is equals to 12. Similarly, we have 2 into 16 to the power 1, which will be equals to 2 into 16, which will be equals to 32. So the final answer will be 44 to the base 10. Why? We have to add these two values. Okay, so 2c to the base 16 can be written down as 44 to the base 10. Okay, so this is what you have to do. You have other methods also. Okay, you can write it down directly. Okay, like let's say we have 2 and c to the base 16. What you can do is c is equals to 12, so you have to multiply it by 12 into its place value, which is equals to 1. Then we have to add it with 2 times 16. The place value of the digit 2 is equals to 16, so it will be 2 into 16, so that will be equals to 12 plus 32, so 44 to the base 10. Okay, 44 to the base 10. And you can also do it by using the arrow method. Yeah, you can also use the arrow method. That will also work, like 2c to the base 16. So you have c here, so you have to multiply 12 into 1, so that will be equals to 12. And then here we have 2, so 2 into 16, which is equal to 32. So the final answer will be 44. Okay, so whatever the method you choose, make sure you don't make any careless mistakes. Okay, I prefer this method because this is straightforward, so I can use it whenever I want. You can choose any method that you like. Okay, now let's do a practice question. Okay, something like a fun one. Yeah, let's say we have to change uh, ace, KACE to the base 16 to, well, we know, into decimal numbers. So here we have E, which is equals to 14 in the decimal. So 14 into base value 1. Okay, plus here you have C, which is 12. Okay, so 12 into the place value of 16, plus a is equals to 10. So 10 into 256. Why am I putting 256 here? Well, this has the place value of 16 to the power 0. Okay. And this has the place value of 16 to the power 1. And this has the place value of 16 to the power 2, which is equal to 256. Okay. So this will be equal to 14 plus 12 into 16 will be equal to 192, plus 10 into 256 is just 2560. So if you add these things, you will get 206 and 2766 to the base 10. Okay, so this is how you have to do it. Okay, this is how you have to do the question. Okay, now let's try a bigger one. Yeah, now let's try a bigger one. Maybe like, I don't know, like 3E8 and F, 3E8 and F. Yeah, let's try that. So let's convert 3E8F to the base 16 to decimal. So we know if this equals to 15, so you have to multiply by 1 because that's the place value of F. Then you have to multiply 8 into 16. Then you have to multiply 14 into 256, and then we have to add the 3 times 16 to the power 3. Okay, so 16 to the power 3 is equal to 256 into 16. So that will be equals to 6 into this is equal to 256 and 1 2 405 no, 4006 and 40 9, yeah, 4096. Let's just do it. Yeah. So we have 256, and then 6 into this one will be 121536. Yeah. So that will be equals to 4096. 4096. And we have to multiply it by 3 again. Well, that's going to be fun, but let's do one by one. Yeah. Let's do one by one. So 15 into 1 will be equals to 15, plus 16 into 8 will be equals to 128. Yeah, 128, plus 14 into 256 will be equals to I think if I subtract 512 from this, I will get 3584. Yeah. Plus 3 into 4096 will be 12288. Okay. So if I add all this, I will get, I think, 143 and 3643, 3727, and if I add 3727 here, 15, 9, 16, 0, 1, 5, I guess. 16, 0, 1, 5. Shall we check? So this will be 143. If I had 143 here, it will be 3727. And if I add 12288 with 3727, what will I get? Well, 15 and 15, 9, so 16, yeah, 16015. 16015. Okay, so this is what you have to do. So this is what you have to do. Let's try another one. Maybe like 1000. Yeah, 1000 to the base 16. What will it be equals to? Well, here we have 0, so we don't have to care about 0 into 1. Also 0 into 16, also 0 into 256. We just have to care about 1 into 4096. Yeah, that will be 1 into 4096. So we can directly write down 4096 to the base 10. Okay, and we can try something like 3432 to the base 16. So that will be equals to 2 into 1 plus 3 into 16 plus 4 into 256 plus 3 into 4096. Okay, so 2 into 1 will be equals to 2, and 3 into 16 is equals to 48. 4 into 256 is equals to 1024, and finally 3 into 4096 is equals to 12288. 12288. So the sum will be equal to 50, so we don't have to care about this. We come here, it will be 13,312. 13,312. So 13,362 total. So it will be 13,362 to the base 10. Now let's convert floating point numbers of hexadecimal to decimal numbers. Let's say we have to convert 23.1 to the base 16 to decimal numbers. First of all, let's draw the abacus. Here we have three places. So let's fill up the places. So we have 2 here, 3 bits here, and 1 bit here. Here we know it is equals to 16 to the power 0. The place value is 16 to the power 0. So this must be 16 to the power 1. And this one, we have to reduce the power by 1. So it will be 16 to the power minus 1. Here we have the value of 16. Here we have the value of 1. And here we have the value of 1 over 16. Okay. So which is equals to 0.0625. Okay. So now what we have to do is, since we have 3 bits for 16 to the power 0, so we can write down 3 into 1, which is equals to 3. Then we have 2 bits for 16 to the power 1, so it will be 2 into 16, so 32. Then we have 1 bit on 16 to the power minus 1, so it will be 1 into 0.0625, which can be given as 0.0625. Okay. So the final answer will be, if you add these three, so the value will be 35.0625 to the base 10. Okay. So I will write that down here. 35.0625 to the base 10. That's it. So let's try another question, like 243.5. So here what we have to do is, so here we have, this is the base 16. So here we have 3, the value, base value will be 16 to the power 0, which is equals to 1, plus 4 into 16, plus 2 into 256, plus 5 into 0.0625. And that will be equals to 3 plus 64 plus 512 plus 0.0625. write this down as 67 and 579.0625 to the base 10. So this is how you have to tackle these types of questions. This concludes the conversion from the number systems to other number systems like decimal to other number systems. Now we have to focus on how we can convert the decimal number, the floating point decimal system number to other number system. You can try it in your own time. Okay, I will just give you an homework. You can check from other resources, and let's look at that tomorrow. So let's say we have 10.25 to the base 10. What if I ask you to find the binary equivalent and octal equivalent and hexadecimal equivalent for this specific number?
Thanks for watching the fifth video in our number system series. If you found this tutorial on converting between decimal and hexadecimal numbers, including floating point numbers, helpful, don't forget to like, share, and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master number systems, and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.